Hello and Assalamu alaikum. This is IGCSE Paper 2 Chemistry Extended February March 2022 Paper 2 total time for which is 45 minutes and total marks 40. So let's start. Question 1. Which gas has the fastest rate of diffusion? So this is a reoccurring question, recurring question. The rate of diffusion depends on the MR. So the rate of diffusion is inversely proportional to the MR, meaning that the higher the MR is, the lower the rate of diffusion. So we just have to calculate the MRs. H2 will have 2 mass of 2, CH4 will have 16. We just add the individual masses, and over here 12 plus 16 times 2, so 44. It is pretty evident that the answer is A because hydrogen has the lowest MR. Next, in which state does 1 dm cube of methane contain the most particles? As a gas at 100 degrees Celsius, as a gas at room temperature, as a liquid or a solid. So, suppose this is 1 dm cube. This is 1 dm cube. If it is a gas at 100 degrees Celsius, the particles will be the furthest apart. So, less particles will be needed to fill up this space. And if it is a solid which has particles really close to each other, many particles will be needed to cover this entire space. This is just a common logic. You have to relate with the structure of the different states of matter. Next, which statement explains why isotopes of the same element have the same chemical properties? So chemical properties are dependent upon electronic configuration, electronic structure, or the number of outer shell electrons. So option A, as they have the same electronic structure. Because in isotopes only the MRs, or maybe you can say the mass and the nucleon number is different. The proton number is also the same, but the chemical properties do not depend on the proton number, they depend on the electronic structure. So A is the correct answer. Next, the electronic structures of atoms P and Q are shown. P and Q form an ionic compound, which means there will be a transfer of electrons. What is the formula of the compound? So the compound P has six outer shell electrons, 2, 4, 5, and 6. So six outer shell electrons means it is in group 6, so it needs two more electrons to complete its outer shell electron to have a stable ionic and a noble gas configuration, which means it should have 8 electrons in its outer shell. And as it is in group 6, so it is an anion which will have a charge of -2 because it needs two electrons. Now, as for Q, Q has one electron in its outer shell, which means that it is in group 1, indicating that it needs to lose one electron in order to gain a stable configuration, electronic configuration. So this will lose one electron, and this needs a total of two electrons. So one electron will be given from one atom of Q, and we will need two atoms of Q so that we can neutralize the charges. Because we need two electrons to be lost by this atom, but only one electron can be originally lost by this, so we will have two atoms for Q to give the two electrons to P. So the charge of Q is, or easily, or putting it simply, you can just do it like this, that Q is in group 1, so it will have a charge of +1, and P is in group 6, so it will have a charge of -2. The charges will cross multiply. This will be Q2P. We don't write the signs over here, we just write the number of atoms. So this indicates that one Q will give one electron, so 2Q will give two electrons, and one P will take both of these electrons. So Q2P, or maybe you can write PQ2 as a formula, because in the option we have this only. It's the same thing basically. Next, this question and many other questions are also present in the core paper also. So they are very basic. Fermentation of sugar produces a mixture of ethanol solution and solid yeast. How is the solid yeast removed from the mixture? As it is insoluble and it is a solid, it will be removed by filtration. The yeast will remain here, and the ethanol will be collected over here. Next, which row explains why copper is a good conductor of electricity at room temperature? So conduction of electricity is dependent on two things, free ions, or maybe we should say mobile ions or mobile electrons. So in metals, what happens is we have this structure of metals in which this is the cation, and we have these electrons over here surrounding them, which can move freely. The cations don't move, the electrons move. So you just have to remember this. Option B is correct because copper ions do not move and electrons do move. Next, this is also from the core. Which pair of statements about diamond and graphite is correct? Diamond and graphite are both pure carbon. They're both macromolecules. Correct. Macromolecules means they have a giant covalent structure and they are both allotropes of carbon. Next, diamond and graphite can both be used as electrodes. No, diamond does not conduct electricity, so not used as electrode. Graphite does not have ionic bonds. Both are covalent molecules. Covalent bonding. Diamond is hard. Yes, graphite is soft with a low melting point. Not true. Graphite also has a very high melting point, close to diamond. Next, sodium nitride contains the nitride ion N3 minus. Sodium nitride is unstable and decomposes into its elements. So this is the key. What is the equation for the decomposition of sodium nitride? So first we need to have this formula of sodium nitride. Sodium is in group 1, having a charge of +1, and N3 minus we are told already, so this will cross multiply and we will have Na3N. This is the formula for sodium nitride. So they said that it will decompose into its elements. So the elements are sodium and nitrogen. So we write a 2 over here with nitrogen because it is a gas and all gases except the noble gases exist as diatomic gases, meaning they have two atoms together. Now we just have to do the balancing. So we have two nitrogens over here. So we should have two nitrogens over here. Now we have six sodiums over here. So we should have six sodium over here, which will be make this a balanced equation. So this is wrong. This is wrong. This is correct. Next question. Compound X contains carbon, hydrogen, and oxygen only by mass. It contains 26.7% carbon and 2.2% hydrogen. Now, oxygen percentage is not given. We have to calculate it ourselves. Oxygen is, we know that the total percentage will be 100. So if we subtract the percentage of carbon and hydrogen from 100, we can know about the final percentage of oxygen. So that will be 71.1%. Oxygen is 71.1%. So what we do is we write the elements like this, and then we divide all of them, divide by MRs to convert into moles. So 26.7 divided by 12, 2.2 divided by 1, 71.1 divided by 16. So divided by 12 will be C 2.225, H 2.2, O 71.1 divided by 16, which will be 4.44. Now we should empirical formula means that I guess I didn't read the question completely. What is the empirical formula of X? So they're asking about the empirical formula. Empirical formula is the simplest whole number ratio of the elements in a compound. So the simplest whole number ratio will be calculated by dividing all of these by the smallest of them of the three. So the smallest is 2.2. If we divide this by 2.2, it will give us 1. And if we divide this by 2.2, this is also 1. And if we divide oxygen by 2.2, I guess this will be 2. Yes. So CHO2 is the correct answer. Option D. So option D is correct. Next, cesium fluoride is an ionic compound. Again, same in the core. Which statements about cesium fluoride are correct? So ionic compounds properties, you should be remembering these, the properties of ionic compounds, their melting points, boiling points, etc. It conducts electricity when solid. No, they don't have mobile ions in solid, so they do not conduct electricity in solid. They only conduct electricity while they're molten or in aqueous state. Next, it has a high melting point. Yes, it is soluble in water. Yes. Next, it is highly volatile. This means that they can turn into gas easily. So, meaning that they have a low boiling point. So, this is not correct. They have a high boiling point. So, only option statements 2 and 3, which means C is correct answer. Next, which diagram shows the direction of movement of ions and electrons during the electrolysis of molten sodium chloride? Okay, so first we have to decide what is the correct anode and cathode and where each of the Na and Cl will go. Ions, Na and Cl ions will go. So the anion goes to the anode, and the anion in this case is chlorine. So any option having chlorine going to the anode will be correct. So, and any option having chlorine going to the cathode is incorrect at the first glance. So, this is also incorrect. We are left with A or D. Now we know that sodium is plus, meaning that it has lost an electron to become an ion. Now it needs to be discharged. It needs to become an atom again. So it will gain the lost electron again to become a neutral atom once again. As for Cl minus, it had gained an electron to become an anion. So now in order to become an atom, it will have to lose the electron it originally gained. What the chlorine atom does, it gains an electron. What the chlorine ion will do is it will lose an electron to become this again. So the electron will be lost at the anode and the electrons will be moving away from the anode, which is correct in option A. In option D, this looks that Cl minus actually what it did was it gained an electron when it came to the anode. This diagram is showing this. While what happened is that the Cl gave its electron. So what will happen is that electron will go like this and go to the cathode, and the Na plus will gain that electron back and become Na metal atom. So this is what the story is. Over here, this looks like Cl will give the Cl. No. This shows that Na will give the electron it had taken, whereas Na did not take an electron. So it cannot give an electron like this. So option A is correct. Next, calcium carbonate reacts with dilute HCl to produce carbon dioxide. The equation for the reaction is shown. The relative formula mass of calcium carbonate is 100. Okay, 10 gram of calcium carbonate is reacted with an excess of dilute hydrochloric acid, which mass of carbon dioxide is produced. So we have the known over here. Known is the calcium carbonate. We have the MR and the gram. So it is a three-step process in every mole question, pretty much. That first we calculate the moles of the known quantity, the known substance, and then from that we take the ratio of the unknown and known to find the moles of the unknown which are formed in the reaction, and then depending on what they ask us, whether the volume or the mass in grams of the unknown, we have to calculate it through another formula. So if we calculate the moles of calcium carbonate, there will be gram over mr. So the gram is 10 gram. 10 over 100 will be 10 over 100 will be 0.1. 0.1. So the mole ratio is 1 is to 1. So carbon dioxide will also have 0.1 moles being formed, and we want the mass. So mass is basically number of moles multiplied by mr, which will be 0.1 times the mass will be of carbon is mr is 12 plus 32, which is 44. So 0.1 times 44, which is 4.4. The correct option is C. Next, molten sodium chloride, which means that the ions are Na plus and Cl minus, and concentrated aqueous sodium chloride, which means the ions are Na plus, H plus, Cl minus, OH minus, are electrolyzed using platinum electrodes. What are the products at the negative electrode, which is the cathode in each electrolysis? So at the cathode, the cation is being discharged. So we will ignore all anions. Only cations will be observed. So in molten state, we have only one cation and Na plus. So in molten, hydrogen cannot be present. In concentrated aqueous sodium chloride, we have Na plus and H plus. So the thing is, we have the entire the reactivity series in which hydrogen comes way below Na. So the element which is down below is given the preference to discharge because it is less reactive. So it easily gains back its lost electron. So we have option C as the correct answer. Next, an object is electroplated with silver using an aqueous silver salt as the electrolyte. So, which row is correct? The object to be electroplated is the anode or the cathode. The other electrode is made from either carbon or silver. So let me show you from this diagram. Just ignore the Na plus and the electrons. What they're asking is that we need to electroplate a coin with silver, for example. So where should we place the coin and where should we place the silver? On the which will be on which, the cathode or the anode. So what happens is the current first flows to the anode. The current flows in this direction. So what happens is this is dissolved into the solution because this is containing the same ions. These ions go over here at the cathode and they from here dissolve in the solution, and from here the silver is deposited over here. So naturally, if we wanted this to be electroplated with silver, so we will make this with silver, and this electrolyte solution will also have silver. So what will happen is this will interfere with the reaction and dissolve over here, and from here the pure silver will be deposited on the coin. Next, so the correct option is the cathode will be of the object to be electroplated, and the other electrode is made from silver. Next, which row describes the changes that occur in an endothermic reaction which energy absorbed? Endothermic is a reaction in which energy is absorbed. So energy given out to the surroundings, no. Energy given out to the surroundings, no. Energy taken in from the surroundings, yes. Temperature decreases, yes. When energy is absorbed, so the temperature is decreased. This is just the opposite. Next, which statement about fuels is correct? Heat energy is only produced by burning fuels, no. Not only heat energy, the light energy is also produced, and burning fuels is not the only method to get heat energy. Hydrogen is used as a fuel, although it is difficult to store. True. Hydrogen is used as a fuel and it is difficult to store because of its explosive nature. Next, methane is a good fuel. Yes, it is, but because it produces only water when burned, no. Every organic compound, when it is burned, it produces carbon dioxide plus water. Uranium is burned in air to produce energy, again, not burned in air. Which statement about endothermic and exothermic reactions is correct? Okay, so in endothermic reactions, energy is absorbed to break the bonds, and endo energy taken into to break bonds, and in exo energy released to not to when bonds are formed. So now we can look at the question. First, we get our theory together. In an endothermic reaction, less energy absorbed in bond. Okay. Now, this is the process itself. The endothermic exactly means energy absorbed to break bonds, and an exothermic means energy released when bonds are formed. Now, what is an endothermic reaction? The entire reaction is endothermic when more energy is absorbed than energy released, because that's why we will get the enthalpy change as positive, the energy overall energy change. So the energy absorbed is greater than the energy released. Now, there are two things you have to remember while answering the question. One is whether energy is absorbed or released in endo and exo respectively. You need to be confirmed. Energy is absorbed in endo and energy is released in exo. This much. And that energy is absorbed to break bonds in endo and energy is released when bonds are formed in exo. Now we look at the question. In an endothermic reaction, less energy is absorbed in bond breaking than it is released in bond forming. No, more energy is absorbed in bond breaking. Next, in an endothermic reaction, the activation energy is always higher than in an exothermic reaction. Okay, so let's draw the curve of an endothermic reaction and an exothermic reaction. So this is an endothermic reaction and this is an exothermic reaction. So the activation energy is from the reactants to the peak, which is this, and in an endo, it is from the reactants to here. Now this appears to be true. Let's look at the other options. We we're not confirmed yet. Next, in an exothermic reaction, more energy is absorbed in bond breaking. No, 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 no. All of it is wrong. Then is released in bond forming. No, that's not an exothermic, that is endothermic. In an exothermic reaction, the reactants are higher on an energy level diagram than the products. So this will be the reactant in an exothermic and this will be the products on an exothermic diagram. So this is for definite true. This can vary. This can vary. We can have either like this maybe. We can have it like this or this can be an endothermic reaction and an exothermic can be like this or maybe it can be like this. So the activation energy can vary depending on the reactants itself. Now this is universal. This is always true. So this is never wrong. So always make sure to read all the options because you can be mistaken. And what they did was they told us is always higher. This is not true. Always. Next question. The reaction used to manufacture ammonia, which we know this is the Haber's process, from nitrogen and hydrogen is reversible. An equilibrium is established between ammonia, nitrogen, and hydrogen. Which statement describes the equilibrium? So we know the equilibrium definition. Both the forward reaction and the backward reaction have the same rate. Yes, the rate of forward reaction equals the rate of backward reaction in a closed system. This is a textbook 2 mark definition for dynamic equilibrium. This is not correct for the in equilibrium. This is also not correct. And the reactions have not stopped. This is a conceptual mistake if you're making it. The reactions are in progress, but the rate of the forward and backward reactions both are equal. Next, how does increasing the concentration affect the reacting particles in a chemical reaction? So when you increase the concentration, basically you increase the number of particles per unit volume. So per unit volume, there are more particles now. So more chance of collisions. So yes, collision rate increases. Now, increasing the proportion of particles with the activation energy. So this is done when you increase the temperature. You provide the heat energy for the particles to gain the activation energy. So this is not true just by increasing or decreasing the concentration. Methyl orange is added to dilute hydrochloric acid and to aqueous sodium hydroxide. What is the color of the methyl orange in each solution? So it is red in acid and yellow in sodium hydroxide. This is pretty obvious. You just have to remember this and memorize this from the notes for qualitative analysis in your syllabus. It is all given. The this and the test for gases, the test for cations, anions, everything. Zinc oxide is an amphoteric oxide. What are amphoteric oxides which can react with acids and bases? Basic oxides are which react with acids and acidic oxides are which react with bases because same nature substances do not react, opposite nature substances react. But amphoteric is somewhat you can say something in between which can react with both. It is not neutral or you can say it as a neutral, but it reacts with both. Which types of substances will react with zinc oxide? So we decided acids and bases. Acids only no, no, no. Information about some silver compounds is given. Silver carbonate is insoluble. Silver chloride is also insoluble. Nitrate is soluble, and silver oxide is again insoluble. Now, which equation shows a reaction which cannot be used to make a silver salt? So, all of these are correct basically because they have a salt reacting with an acid, salt reacting with an acid. or maybe over here an oxide reacting with an acid, there's no problem with these. And yeah, there's basically no problem with these reactions. But for here we have the reactivity series problem. Ag cannot displace H because it lies below hydrogen in the reactivity series. So silver cannot displace hydrogen. It is less reactive than hydrogen. Next, aqueous ethanoic acid is a weak acid. Weak acid means it partially ionizes. Partially ionizes. Next, aqueous sodium hydroxide is a strong base, meaning fully ionizes. Aqueous ethanoic acid is neutralized by aqueous sodium hydroxide. Which statements are correct? Aqueous ethanoic acid accepts proton? No. Proton donors. Acids are proton donors. Proton acceptors are bases. The aqueous ethanoic acid used is fully dissociated. We just recognize that there is partial ionization, partial dissociation, same thing. The aqueous sodium hydroxide is fully dissociated into ions, yes, because it is a strong base. The reaction produces a salt and water, yes, neutralization of a acid base always produces a salt and water, so 3 and 4, option D. Next, three properties of element X are listed. It contains atoms with a full outer shell of electrons. By looking at this, you should recognize that full outer electron shells in an atom. It can be present in any ion, but in an atom, when we are saying, then it is always the noble gases, the group 8 elements. So we don't even need to read. But if even if we do, it is monoatomic. Yes, they are gases, and they're the only gases which are monoatomic, meaning they exist as single atoms. Helium, neon, etc. It is unreactive, yes, because they have a full outer shell electrons. They do not react and do not lose or gain electrons. Next, which word equation represents a reaction that occurs? Now you have to keep in mind what have you studied because that will be for confirms the correct answer. So the carbon does not displace sodium. The iron does not displace sodium because sodium is at the top of the reactivity series. The copper does not displace iron because copper is below iron in the reactivity series. But this reaction is in fact possible because iron 3 oxide, we have studied this in the extraction of iron Fe2O3 plus coke or carbon is producing Fe plus carbon dioxide. So this is the decomposition, or maybe you can say a reduction reaction or a redox reaction in which carbon reduces iron 3 oxide. Next, which statement about the extraction of aluminum is correct? Aluminum is formed at the cathode. Yes, aluminum is the cation, so it deposits on the cathode during the electrolysis of aluminum oxide. That is the method used to separate aluminum from its ore. Next, hematite. Hematite is for iron. For aluminum is bauxite. The entire chapter is best to be studied from the syllabus of metals. Molten cryolite, it is used to lower down the melting point. Lower the melting point. Next, oxygen gains electrons. No, oxygen gives back the gained electrons earlier. Next, metal M is mixed with copper to produce brass. So brass is an alloy containing copper and zinc. This is pure recall, option D. Next, the table gives some properties of an element. The appearance of the element is gray. Okay, it is a metal. Melting point in degrees Celsius, it is really high. So probably transition elements or group one, maybe. But here we see that it forms the appearance of the chloride is dark blue, meaning it formed a colored compound, which is the sole property of transition elements. Next, the density is also very high and it conducts electricity when it is in solid, so it can none other be, it can be nothing except a metal. So transition elements, we recognize that it is a transition element because of its colored compound and other things. So what other property do transition elements have? They're brittle? No. They form an acidic oxide? No. They form basic oxide because metal oxides are basic. They react highly with water? No. Because they're not that reactive, so they react slowly with hot water. Next, it as a catalyst. Yes, that is true. Ammonia is produced using the Haber process, which shows the source of the raw materials and the reaction conditions. So this is also pure recall. Nitrogen is extracted and it is gained from the fractional distillation of liquid air. So every gas is separated according to its boiling point. So hydrocarbons is wrong. Source of hydrogen is hydrocarbons. Yes. Temperature is, we know, 20,000 kPa and 450 degrees Celsius. So 200 is wrong. We are left with C and D. The pressure, sorry, the temperature is 450 degrees Celsius. The pressure is either 20,000 kPa or 200 atm, atmospheric pressure. So this is correct. This is not option C. Next, question 30. How many species are acting as bases which are proton acceptors? Proton acceptors basically means gain H plus ions. So over here we can see that if this is a reversible reaction, so if we go in this way, we can see that this accepted proton. That's why there is one more hydrogen in this ion. So it was a base. And if you look at this, this lost an H. So this means that when we will go in this direction, what will happen is the NO3 minus should gain the H to become the nitric acid once again. So this is also accepting a proton. The protons are basically hydrogen. So this is 1 and this is 2, option B, because they will accept hydrogen atoms to follow the reaction mixture. Next, the equation for a reaction occurring in the contact process, the manufacture of sulfur trioxide or the sulfuric acid entirely is shown. What is the catalyst used in this reaction? Pretty easy. Vanadium 5 oxide. Iron is used in NH3. Phosphoric acid is used in organic chemistry when steam is added to ethene or alkene to form an alcohol. Sulfuric acid is used in esterification of an acid and an alcohol. Which information about carbon dioxide and methane is correct? So, formed when vegetation decomposes is true for methane. Greenhouse gas is true for both. So, yes, option B. Present in unpolluted air, carbon dioxide is present in 0.4%. This is not present. Produced during respiration, carbon dioxide is produced, methane is not produced. Next, the structure of an ester is shown. What are the names of the carboxylic acid and the alcohol that react together to form this ester? Ester. So the carboxylic acid group is always the one having the oxygen double bond with carbon. So these are two carbon atoms, which means that the carboxylic acid has two C's, the name for which is ethanoic and not propanoic. The alcohol is basically containing three carbons, so it should be propanol. Next, which statements about lime are correct? Lime is basically calcium oxide. Lime is made by heating calcium carbonate. When we heat calcium carbonate, this is the reaction that happens. So yes, calcium oxide is formed. So this is true. Lime is used to desulfurize flue gases. Yes, you just have to remember this. Alkaline soil, no, it itself is alkaline because it is a metal oxide. Next, the chemical name for lime is calcium oxide. I already told you this. So 1, 2, and 4 are correct. Option B. 35, which structure is correctly named. So now we have to see the number of carbon atoms, whether they're correct or not, and the functional group. So the functional group in the first option is acid, carboxylic acid, which is COOH. So it contains that. Now for the carbon number of carbon atoms, it is ethane, which means it should contain two carbon atoms. So this is the incorrect answer. Next is ethene. It does not have a double bond. That is the functional group of ethene. So not correct. The number of carbon atoms are correct though. Ethanol, this is containing the alcohol group and two carbon atoms, so correct. Next is propane. Again, a double bond is present, which which is present in alkenes, not in alkanes. So option C is correct. Next, the structure of a part of a polymer is shown which monomers can be used to make this polymer. So what happens is when addition polymerization takes place, the double bond breaks and the compound grows like this. So what will happen is when we reduce it to a monomer, that this continuation will stop. There will be a double bond over here and one H will have two, one, two, three, four. No. Yes, so this will be separated. First, you have to identify the repeat unit where the compound is repeating. So if you look at here, if you look here, this is one repeat unit and this is another. You notice the difference. This is the same, this is the same, and this is the same, and this is the same. So these are two repeat units like this. Now what happens is this double bond breaks and it forms a monomer again. This is for the first two carbons, and this is for the second two carbons. Oh, sorry, the last two carbons because the double bond will come over here again. So C double bond C H CH3 and Cl and H. So this can be used and this can be used in the options given. It is this and this. So both are correct, 1 and 2, 36A. 37 with carboxylic acids are made by the oxidation of alcohols, which carboxylic acid is produced from CH3, CH2OH, which is basically ethanol containing two carbon atoms. So when we add oxygen to when we oxidize it, basically the acid form should also be the acid form should also be containing two carbon atoms, which is ethanoic acid. Butanoic contains four, methanoic one, propanoic three. Next, propene reacts with bromine in an addition reaction, which structure represents the products of this reaction. The product of this reaction. So we have Br2, two Br will come and each will attach to one carbon containing a hydrogen atom. Next, the Br should attach to the double bond. For example, if this is an ethene, the propene, so bromine will come over here and over here as this double bond breaks. So basically, as this double bond breaks, bromine will come here and come here. So the bromine should be attached to two different carbons adjacent to each other. So this seems to be the correct one. This has two bromine on the same carbon. No, on only one bromine. No, two bromines, but on separate carbons, not adjacent to each other. Next, the statements about ethanol are correct. It is used as a solvent. Yes. It can be made directly from ethane. No. First, you have to convert it to ethene, then add oxidization. Ethanol is a covalent compound. Yes. 40. Which diagram represents the structure of nylon? So the monomer of nylon is like this. This is the carbon chain. This is the acid group, and this is another monomer containing a diamine group. So this is a diamine. When these two join, there is condensation. And what happens is that the OH from the acid and the H from the NH2 goes away, and this is the new product. So this is the amine bond, amide linkage, and this will continue. So this is what you're looking for. So in option one, we have an O over here indicating that this was a diol. So that is PET, not not nylon. So wrong. This is seem to be correct, but it has different functional groups on a single carbon chain. We have the same functional groups on one single chain. Next is the correct answer because it is following all rules. It is applying wholly to this. As for option D, this again has two different functional groups, and one is of the diamine and one is of diol. So I don't know uh, what's happening over here. This is entirely incorrect. Only option C is correct. So we have completed the paper. Thank you. Jazakallah khair.